The intended function of a program or part of a program can be specified by making general assertions about the values which the relevant variables will take after execution of the program. Welcome everybody, it's Amel, and today we're going to solve largest values from labels. We have a set of items. The ith item has values of I, and labels of I. Then we choose a subset S of these items such that the cardinality of S is less than or equal to none wanted. So this means that the size of the subset cannot be bigger than none wanted. For every label L, the number of items in S with label L is less than or equal to use limit. So this condition means that we can pick items that have the same label, but those items that have the same label, they cannot be more than use limit. So for example, if use limit is 1, then we cannot pick more than one item with the same label. Then return the largest possible sum of the subset S. For example, here this is example 1. These are the values and these are the labels. So you can think of these 5 as the value for the first item, and the label for the first item is 1. The 4 is the value for the second item, and the label for the second item is also 1, and so on. So we have these values: none wanted equals 3 and use limit equals 1. So the output is 9. So we want to maximize the value, and we want to make sure that we follow these conditions. So the explanation is that in this case we can choose this item that has value 5, and we can choose this item that has value 3, that's 8, 5 plus 3 is 8, and we can also choose this item that has value 1, so 5 plus 3 plus 1, in total 9. So this is the maximum value that we can get. So in this particular case, we cannot choose 4 after choosing 5 because 4 has the same label as the 5. The item that has value 4 has a label of 1, and the item that has value 5 also has a label of 1. So after picking the one that gives you 5, we cannot pick the 4 because they have the same label and the use limit is 1. So that's the reason. So how can we solve this problem? This is an optimization problem. This is an optimization problem, and we want to maximize the value. So whenever we have to solve optimization problems, we can think of greedy algorithms. A greedy algorithm is an algorithm that makes decisions that are locally optimum at every step, and it never changes that decision. So in order to use this approach, in order to use the greedy approach, we can use a priority queue. So we can use a max heap or priority queue because we want to maximize the value. We always pick the largest value, and we also use a hash map because we want to establish a mapping between each label and the number of times that the label has appeared, how many times the label appears in the data, because we want to make sure that we follow this condition here. For any item that we pick, we need to make sure that we don't pick more items with the same label than we are allowed. That's why we have to use a map or a hash map to establish the mapping between the label, between each label, and how many times the label appears. So without further ado, I'm going to write the code. So as I said, I need to use a priority queue or a max heap. The max heap is going to maintain the largest value at the root. It's going to maintain the largest value at the root of the heap. So I'm going to have a priority queue, and this priority queue is a priority queue of item gets the value of new priority queue, And by default, the priority queue is a min heap. That means that the value at the top will be the smallest value, but I want to use a max heap. So in this case, I'm going to say item 1, item 2, and item 2 that value minus item 1 that value. So I'm doing this here, I'm passing this lambda function because I want to make sure that we compare each item based on the value of the item, not on the label. And I also want to make sure that we use a max heap. So the item that has the biggest value will be at the top. Now this class item, I have to make this class. So I can go down, I can say private class item. So I'm going to have a integer label and also the value. And then I'm going to define a constructor for the label and also for the value. So I can say this that label, the label for this object, for this item, gets the value of the label that I pass, and this that value gets the value of the value that I pass. So now I have this class in order to hold information for an item, and I have the priority queue, and this is a max heap, so it's going to compare by value, and it's going to have the item that has the largest value at the top. So now I just need to populate this priority queue so I can traverse all the items. So for integer I gets the value of 0, I is less than labels that length plus I. Then I can say for each item, right? So make a new item. So priority queue that offer, I'm going to insert a new item in the priority queue. The label for the item will be labels of I. And the value for the item is going to be values of I. So now my priority queue has all the elements. So it's going to maintain the elements using the property of the max heap. So the value at the top will always be the maximum value or the maximum item that contains the biggest value in the heap. So now I want to have a variable max sum. So this is going to be the final result. I'm going to return it at the end. And I also want to have a hash map because I want to maintain a mapping between each label and its count. So I'm going to have a map from integer to integer map gets the value of new hash map. Now I need to have a while loop. So while not priority queue that is empty, and the other condition is that the size of the subset cannot be more than 3. So I need to make sure that num wanted, and it cannot be more than num wanted. So num wanted is bigger than 0. So the other condition is that the size of the subset cannot be bigger than num wanted. So I have to say num wanted is bigger than 0, right? Because every time I'm going to subtract 1 from num wanted. So each time I want to get the current item from the priority queue and remove it. So that's going to give me the biggest item, or the item that has the most value. So I'm going to say item current gets the value of priority queue dot poll. And now I want to make sure that I establish the mapping between the label of this item and its count. So I'm going to say map.put cur.label map.get or default cur.label 0 plus 1. So in this case I'm mapping each label to its count. So for example here I'm going to get the count that I already have and add 1 to it. However, if it's not there, if the label has not been seen before, then I just get 0 by default. So the first time I see the item, the count will be 1. The next time it's going to be 1 plus 1 is 2, and so on. So after I put this mapping here, I can check if map.get cur.label. So the other restriction is that it cannot be bigger than use limit. So it's less than or equal to use limit. Then that's okay, I can pick this item. So this is the item that has the most value, and I know that I have not picked the label more than use limit because I'm checking here. So because I haven't reached the limit for this label, then I can choose the value of this label, which is the maximum that I have in the priority queue, because this is a max heap. So I can simply say max sum plus equals the value of the current item. And because I picked one more item, I have to decrement num wanted. So minus minus num wanted. So now I'm going to run the code. I'm going to submit my solution. It's working perfectly. So the time complexity is big O n log n, where n is the number of items, and the space complexity is big O of n, where n is the number of items. If you like this video, please press the like button. Don't forget to subscribe, and see you next time.